asking how much is the PL max, what's the maximum load we can have without overloading this generator. If it was a perfect load, we should be able to give 1400 kilowatt, right? We have a 2700 kilowatt, but we cannot. We're going to go over to see how much is the maximum we can provide here. Which one of these generators they are going to generate? G1. Why? Because delta F is how much? 1.5 hertz for G1, right? For the other one is how much? 2.5, right? So definitely G1 is better one, right? Now let's write the equation. You know, you can go through the drawing or you can write the equation. You can say, if I go for G1 is like this, right? This one is F and this is the P, right? So basically I have a F and L and I have a FF. I write the equation for this line. What's the equation for this line? F1 is going to be how much? The slope of this, right? How much is the slope of this one? Minus 1.5, right? Divided by 700 times P1 plus how much? If P1 is 0, how much should be F1? FNL, exactly. How much is FNL? 50. Right? Is it correct? Is it correct? They're looking very strange. Huh?
I asked you.
No, no, that's now. You get it. See, this is the line, right? This one is the FNL, is when P is 0, right? P is 0. And this is the F full load, right? F full load 48.5 at how much? 700 kilowatt, right? This is 700 kilowatt, right? So we can say how much is this one? 1.5 divided by how much? 700, right? But the slope is negative, right? Minus 1.5 over 700 P1. And you said if P1 is 0, how much is frequency? F and L, right? So if I put 0 here, this one should be 50, right? So F1 will be 50. How about F2? Minus 2.5, right? Over 700, P2 plus how much? 50.5, right? Now, we're going to go back to the equation, to the part. He said if you have a 1200 kilowatt load, how much is the PG1 and PG2, right? I have equation number 1, I have equation number 2, I'm going to have equation number 3. What's the equation number 3? They're going to work with the same frequency, right? And what's the equation number 4? Exactly. Right?
What's frequency was F1 equal to?
When they are parallel, they are working together. This is individual, right?
Yeah.
When they are not connected together, right? But when they connect together, they are going to work with the same frequency. They are going to end up at some frequency, right? Which they are going to work with the same frequency, right? So now if you solve this one, you are going to get this answer. P1 is going to be 662 point. Before going there, hold on. What's your expectation? P1 is going to be more power, right? You know, this is kind of quick double check. You know, if you calculate P2 more than P1, means something is wrong in your equation. You know, because P1 is a better generator, right? 66.24 kilowatt. P2 is going to be 537.6 kilowatt, and the system was going to work with the frequency of 48.58 hertz. So they're going to share the load like this, right? One is going to give us 660, the other one is going to give us 540 kilowatt. Now you tell me how to solve the B part.
Set the frequency at 48.5.
Set P1 to max 700 or F1 equals 500.
Why you are setting P1 to max?
Because because P1 is the first generator is.
P1 is the one who's going to hit the max first, right? So we'll put the, let's see, if P1 is a 700 kilowatt, right? If P1, that was the A part, D part. We said if P1 is a 700 kilowatt, why I'm putting P1 700 kilowatt, just based on what I'm seeing here, the one is going to hit the 700 kilowatt first, is going to be this one, right? So let's set to the 700 kilowatt. If we put 700 kilowatt, how much is going to be F1? Yes. I don't know, we calculate, I don't know. Yeah, it's going to be, you're right, 48 and a half. Right? It's going to be 48 and a half hertz. Right? So now I know the frequency, I can put it here, calculate the P2, right? So I said F2 is equal to F1, so 48.5 hertz is equal to 2.5 minus over 700 P2 plus 50.5. If we calculate this one, P2 is going to be, how much? P2 is going to be 560. So PL max, how much is the PL max? We can support without overloading the generator. I'm not going to overload my generator, right? So 700 plus this one is going to be how much? This is the maximum load I can support for this system. So you can see this is the disadvantage of the generator. They are not exactly similar. Your system is 1400 kilowatt, but you can only support how much? 1260 kilowatt. You know, that's the problem. We would like to, when we are going to parallel units, which we would rather to have the same type of generator, to put them in parallel. Still, they are not going to be exactly the same, even if they are the same brand, everything is the same, but they are going to be very close. For example, here you can go up to, for example, 1380, for example, right? You lose 20 kilowatt, not, and how much here is 140 kilowatt, right? So when you have it exactly similar, I mean, in the real life, maybe you lose 10 kilowatt, 5 kilowatt, something like that. You can go over there, right? So generator with a different characteristic, when you parallel them, you cannot use the maximum capacity. One of them is going to hit the maximum capacity, the other one is going to work under the maximum capacity. Let's go back to, let's stop, I'm going to solve one example. Let me go fix this equation first and come back, and we'll solve one example on this one. And I think we have a time. I'm going to go over the non-salient pole machine. When I come back, we'll go over the equivalent circuit of those ones, and we will learn about that one also. So for today, we are good. And if you have any questions regarding your meter exam, please bring it back. I know there was one person. And Jeremy, we need more time. I'm not going to be here. Can you come here? First, I'll leave.
You wasted all your money and all your time. Why would you do that? Elon Musk was working on that with this picture. They're working on it.
I saw you. We have a lab.